In this video, we will learn how to derive the demand function from the given utility function. The question is, if the utility function is u is equal to x1 times x2, utility is a function of two goods x1 and x2, and budget constraint is equal to m naught minus px times x minus py times y, where px and py denote the price of good x and y, and m naught denotes the income of the consumer. Then the demand functions are, we need to find out whether the demand functions are vertical, rectangle, hyperbola, horizontal, or parabola. Okay, so first thing is, given this utility function, what will the consumer do? He will try to maximize the given utility function, which is equal to x1, sorry, it is x into y here. Okay, x into y, so we have x times y is the utility function of the consumer. So consumer wants to maximize the utility function subject to the budget constraint that he is facing, that is m naught minus px into x minus py into y is equal to 0. Okay, so we have the utility maximization problem. We have x good and y good. Given this budget constraint, if I draw it here, consumer wants to maximize his satisfaction. So this is our indifference curve. Okay, so for that, consumer will maximize his satisfaction where the slope of the indifference curve is exactly equal to the slope of the budget constraint. Okay, so we have the equation, that is the tangency condition should be, that is consumer maximizes his satisfaction at a point where slope of budget constraint is equal to slope of indifference curve. Okay, so slope of budget constraint is simply the ratio of the prices of two goods, that is px upon py. It should be equal to the slope of the indifference curve, that is the ratio of the marginal utility of good x upon marginal utility of good y. Okay, so to find out the demand functions, first we need to find out the optimal consumption, or rather we need to solve the utility maximization problem, then we can derive the demand function. Okay, so what happens then? So what is marginal utility of good x? And let me write it here. Marginal utility of good x means, or let's write it here, mux upon muy should be equal to price of good x upon price of good y. Mux means the partial derivative of the utility function with respect to good x, and muy means the partial derivative of utility function with respect to good y. It should be equal to the ratio of the prices of the goods. Okay, so differentiating this function with respect to x partially, first derivative of x is 1, so we are left with y. Similarly, du upon dy means the derivative of this function with respect to y, we are left with x only, should be equal to price of x upon price of y. Solving for y, so y will be equal to price of x upon price of y times x. Okay, now we plug this value of y into the budget constraint. Okay, so we have m naught minus price of x times x minus price of y times the value of y which we got here, that is equal to price of x upon price of y times x should be equal to 0. Okay, here py gets cancelled. We are left with m naught minus px into x. Then we are also left with minus px into x should be equal to 0, which implies we have m naught minus, so these are like terms, we can add them, so we get twice px into x should be equal to 0, which implies twice px into x is equal to m naught, or x will be equal to m naught upon twice px. So this is the demand function for good x. Okay, let me write it here. So we got the demand function for good x is equal to m naught upon twice px. So we can see from this equation, this is not a vertical function. Okay, since x is a function of px, so it cannot be vertical, also it cannot be horizontal. Okay, it is not the parabola. In fact, this function, what we call it, is the rectangular hyperbola. So it looks like this. If I draw it here, so let us say we have the x on the horizontal axis, that is the demand for good, quantity demanded of good x, and price of good x is on the vertical axis. So the function will look like this. Okay, so this is the demand function for the given utility function. Okay, so why here x and quantity demanded of x and price of good x are inversely related with each other. Okay, so simple thing, if we have a function y is equal to 1 upon x, we call this as the rectangular hyperbolic function. Okay, so the correct option should be B option, because we are getting this in this fashion. Okay, I hope I make myself clear in this video. Thank you.